Hi everyone, welcome to this video. And in this video, we will talk about um, plotting a scatter plot in our software and how we can find any kind of statistical or quantifiable relationship between two variables. So before we go ahead in this video, let me tell you how and why we should learn this. So first thing, if I give you example of two variables, suppose when you were a child and say 5 or 6 years of age, and as your age keeps on increasing, as your age keeps on increasing, your height keeps on increasing also for a certain age. And then after say you become 21 years or 22 years of age, your height becomes a constant or a straight line. It's not exactly clear, but just to show you one example of two variables. So most of us hold this kind of a relationship that our height keeps on increasing for a certain amount of time with respect to age and height relationship. So now here directly we know that height and age relationship. So it looks very simple. But suppose a situation when you have, say, you want to model something, you want to say you have 10 variables and you have to choose which of the variables affect the output or the decision making. So if I give you example, suppose in a bank, if I have to say ki, why the customer is going out. Suppose I have to answer this question, why the customers are chunking out. And we have say 10 variables that are affecting, say, because they're not finding it interesting, the internet page is not good, customer relationship is not responding to the calls or queries, say n number of factors, or we are not offering good interest rates, n number of factors. Now if I have to see that which of the 5 factors, because we can't model any model of hundreds of variables or 20 of variables, we have to make some models that is realistic and which can help us solve this problem. So in real world, in real life problems, we need these types of relationships to know that how any output or input variables are associated. Based upon that, we can choose that variable and eliminate all other variables which are not associated. Similarly, in those situations, this type of scatter plotting will help you a lot to identify if any of the two variables hold any kind of relationship or not. So I hope why we should read it must be clear right now. Now, in this video, what I'm going to do, I will explain you what kind of a scatter plots is possible and how we will plot this using a live data set in our software. And I will show you our demonstration how different plots can be used and how different interpretation can be taken out. So bear with me and let's start. Let's start the video. And as you can see, so here below figure, if you can see my screen. So yeah, so if you can see, this is a y, right? This is a x, and these are the data points between x and y, two variables and with the data points. Now we have plotted those two variables with the data points, and it is showing that figure one's a strong positive relationship. The reason being, if you come here in this one, figure 3. Now what figure 3 is having, figure 3 is having one problem with respect to figure 1, that it is highly scattered. These data points are highly scattered. Rather than here, if you see, there is one, we can plot one straight line. And if we want to confine figure 1, then the scattering is very less with respect to that line. So it's a very good relationship with respect to figure 1. Figure 1 is tightly coupled, means y variable is tightly coupled with the x variable. But in figure 3, the scattering is a lot. Although both of them right now holding linear relationship, means y and x are directly proportional. So yeah, now if I come to this figure 2, this is a negative relationship. As y is increasing, x is decreasing, right? But same way, here the scattering effect is very, very less, and here the scattering is very high. So it's a moderate negative relationship. It's a very strong negative relationship, means these two variables are tightly negatively associated. These are negatively associated, but not tightly negatively associated. So these are the scatter plots, means these two variables are showing how, with respect to scattering of data sets, that how it is being coupled. So this is how, by plotting these types of plot, we can see the association level. Also, there may be one situation, if you can see this figure 5, and there will be variables which will be scattered a lot. We can't say whether it is positively associated, whether it is negatively associated. We can't plot anything. We can't say straight line. We can't say we can't show any kind of association. So yes, these types of plot is also showing whether these two variables are related or not. No, these two variables are not related. As I started in earlier uh, section, where you have to take a decision, say y equals to function, y is a function of, let me show you. So say y is a function of 5 of 6 variables, right? So if I have to choose, like out of 3 variables I have to choose, then we can plot such types of plots and see if whether they hold any tight relationship or not. Based upon that, if they don't hold, those variables which don't hold any relationship, we can eliminate them while building our model. So there are like a number of ways in which you can plot such scatter plots, right? You can do it in MATLAB, you can do it in R, you can do it Python, but we will prefer R here, R software. And if someone is new, they can just, it's a very free open source software, and it's been designed specifically for these types of statistical analysis. That is why I'm choosing, and it is a free open source software developed by open source community. So it's very simple. Just type, if someone doesn't know, just type this thing in your command window and you're good to go. Just download the software, click on this link and download the software. So I'm not going into the detail of those parts. I hope you have Windows, Apple, or iOS, which type of version, you can download that out. So let me. So as you can see here, I have two data sets now. To start in R console, I'm right now in R console software, and now I will plot scatter plot using two data sets. So firstly, I have one data set which I am storing in variable x using xc, and in the small brackets I have to enter my data points using comma. So see, here I have added my data points. Now it's added. And similarly, I will go for y. Let me, now as you can see, I have entered x and y. So next I will go ahead and, yep. So if you, so there is one issue, let me resolve that. Okay. So let me share our software screen. Now I hope you can see that. I have a little glitch. I hope with me. So what I've done till now is just a very simple thing. I have opened our console, as you can see, and now I have entered variable x using command C, and then these are the data points, as you can see. Similarly, now moving on, I am going to add another variable because we want to identify relationship between two variables. So let me just enter y variables data points, as you can see on your screen. I hope you are seeing that. And done. Now, x and y data points I have given. Now we want to see what kind of a scatter plot or what kind of relationship they are having. So one by one, I will plot different types of scatter plots and we can analyze that. So command for that is very simple, plot plot x comma y. The variable you want at x-axis should be in a x and the variable you want in the y-axis should be on a y. X comma y, and you will hit enter. Now you can see on your screen. So this is what we have got, the data points at x-axis and y-axis. As you can see, it is holding a linear relationship. And if I can show you, then the scattering range should be from here to here. It is pretty much scattered, but it is holding a linear relationship. Now, if I let's do another type of variation scatter plot. So let's plot different points. Let's plot a lines. So for that, suppose you don't want only dots in your screen. You want those data points should be shown as a line. So for that, very simple command you have to do, plot xy, comma, double brackets, and here you will just write L for lines, and you will hit enter. The moment you hit enter, it will show a lined graph. So let me show it where it is. Okay, just give me a second. Now, here you can see it got minimized. Sorry for disruption. Now you can see all those data points which you saw earlier. Now it's been a straight line. So let me show you again. So when we entered plot x comma y only, then we got these data points. Now what that command did, it just makes sure to create simple linear lines as much as possible to show us that data points hold lines kind of a relationship. It will try to show us so that we have better viewing in case the data points scatter a lot. So let me minimize that and let me show you again. Let's clear all this drawing. So it's very pretty simple, I would say. You can go on that and see the data points have become lines now. So similarly, there are different ways now. If you want both data lines and data points, then you can just type B in those inverted commas and see what you get. So see, you can see on your screen, these are the data points. And also data points is being shown as a dot and also as a line, means both. So I hope this is clear. Let's move on and try something else. So we can vary and we can make an overplottation, staircasing, and histogram. So let's see how to make a very clear histogram for that. So you see, so what happened basically, these data points with respect to X, it has just went to those data points on a Y where the dots were or data points were there. So that's how it showed the histogram. I hope everybody knows histogram. And so you can see that how linearly it is going. So it can help you to analyze. See, the data points are linearly rising. So as X is rising, Y is rising. So it is showing how the data sets are behaving with respect to X and Y relationship. Let me minimize that again. There's one more thing which I have to tell you. So what we can do, we can also annotate also. We can make overplottation also. There are n number of things. You can go on a normal Google search and see how different plots can be plotted. So one thing which I would like to show you is the staircase plotting. So let's just make sure we type S for staircase and click hit enter. See, although we can't clearly tell it about it. So these are 4 different variations which we can do in terms of a scatter plot and R. And we can analyze those data points. We can analyze those variables and see which kind of relationship they are holding. So the best one would be simple plotting or say dot plotting, I would say. So as you can see on your screen, which we have started, it is showing linear relationship. Similarly, you can check for any 2 variables and try it at your home. In the next lectures, we will try to go for more detailing, like how we can quantify more, which types of different plots, and how we can get the quantification variable, like a quantification, say 0.2, 0.3, or coefficient of variable, how we can associate those things. So for a single variable, like we used to find variance, mean, and other central tendency statistical quantification numbers. Similarly, for 2 variables or bivariate variables, we will do all those analysis in R and other variations. That's for all. That's all. I hope you must have found it interesting. Please reach out to me if you have any doubt. Thank you so much.